All right, so let's further examine our formula here. So remember that if we have this integral formula and f of x sub I times delta x, or excuse me, got them mixed up here. So f of x dx equals the limit as n approaches infinity of sigma I to, or 1 to n of f of x, and here's where I have the sub I asterisk and then the delta x, right? So remember that this right here, since we're talking about length and width, since our length is f of x sub I, that means that that's the output of the function, right? So the output could be positive like it is here, right, at all these points, or the output could be negative like it is here at all these points. And so you can have negative areas, right? So what happens is when we use this function, what we get is we get the net area, okay? So this is a net area function. We kind of saw that before when we did that. Remember that function that we looked at where we had a little triangle here, right? And then we had a bigger triangle here. And we did this area minus this area. And that's what we verified and confirmed as what we got. We got 6, right? So we're getting net area. So we're getting area above the curve, area above the x-axis, minus the area below the x-axis. Okay, so just keep in mind that that's what we're finding. We're not finding total area, we're finding net area in this case. All right, and here's just maybe a little more clear example with the full area shaded in, but the limit, the definite integral equals area 1 less area 2, right? The area above the curve minus the area below the curve. And that's what our integral equals our definite integral from a to b. Okay. And in this case, a would be, let me just make this more specific, because here we have how we're going from 0 to 2. So this would be from 0 to 2 of this function f of x dx, right? Would equal area 1 minus area 2. All right, so here's the definition. And I skipped a few examples here because I want to kind of start to get into the more of the kind of computational and standard way that we find these. But I just want to point out that we have net area that we've talked about, which is basically what the definite integral is net area under the curve, right? So you could end up with a negative answer if you have more area below the curve than above, or you could end up with a positive, right? Or you could end up with 0, right? You could have something where you have area above and below that are equal, and you end up with 0, a net 0. And so and that's generally what we're going to be using is just the definite integral just like you see it, and just know that that's net signed area below the curve. Okay. All right. Now, if we want total area, if we want to like sum up all the area, like going back to like let's say this one here, if I want total area, then if I want like this plus this instead of the difference of the two, then what I want to do is I want to take the absolute value of the function out. So I'm going to take the integral of the absolute value of that function. All right. And so so we'll talk about that in a minute, but that'll give you area 1 plus area 2. All right, so total area, what I want to do is I want to think of this as, okay, I'm going to take the integral from 0 to 6 in this case, right, of x minus 2 dx, okay? And so so if we want total area, we actually want to, let me take away these parentheses, and we just want to put absolute value, right? And there's a few ways you can do this. You can actually graph this as an absolute value function. So if we were to graph this, x minus 2, so first of all, we want to figure out where does this equal 0. And so this would equal 0 when x equals 2, right? Because 2 minus 2 is 0. So at x equals 2, 1, 2, this is going to cross at 0, this function, okay, or it's going to hit 0. But absolute value functions, instead of going through the line, they actually bounce. They actually make a V, right? And so this is a slope of 1. And so it's going to bounce, and it's going to go up 1 over 1, up 1 over 1. Then it's going to do the same thing on the other side, up 1 over 1, up 1 over 1, okay? All right? And so if we go from 0 to 6, this is 0, right? And then we're going to go all the way to 6. 1, 2, 3, 4, 5, 6, okay? So this will be 6 right here. Okay, so we're going to go from 0 to 6. So now we can see that we're going to have positive area here, right? And then positive area here. And when you have an absolute value function like this, when we take an absolute value of a function, it's always going to all be positive, right? And so then we can find the areas of those triangles. So first we can do this one, which is 2. 2 is the base, and the height is also going to be 2 because the slope is 1. You could also plug in 0 here. And if we did f of 0, that would be 0 minus 2, but it's absolute value. So it's going to be negative 2 absolute value, which is going to be positive 2, right? So this will be 2. So this triangle is a 2 by 2. So that area, let's call this, we'll make this actually purple here. We'll call that area 1. And so that's going to be 1/2 times 2 times 2, right? So I'll do 2 times 2 divided by 2, which is just going to equal 2. All right. And then we'll do this area here. And so this base is 1, 2, 3, 4. And this height, it should also be 4, right? Because once again, the slope is 1. But we can plug in 6 here into this function. And so if we do f of 6, we're going to get 6 minus 2 absolute value. So that's just the absolute value of 4, which is 4. Okay. So this will come across and be 4 right here. So this length is 4. And so it's a 4 by 4. And so we're going to do area equals 1/2 times 4 times 4, or 4 times 4 divided by 2. And so that's going to be 8. Okay. So area 1 is 2 and area 2 is 8. And so we're just going to add those together. So 2 plus 8 is 10. And that's the area underneath. That's the total area, right, of this curve. So, and let me just show you real quickly. If we were to actually graph the x minus 2 function, it would still cross at 2 here. But instead of bouncing, it would go down, right? So it's going to be something that looks like this. All right. And so what we would get is we'd still have that positive 4 area here, right? But we would have a negative area here, right? Okay. And so that's why we do the absolute value. So if we were to do net area, it would be 8 minus 2, right? So it would be 6 if I were to do just regular 0 to 6 of x minus 2 dx. That would be 8 minus 2, which would be 6. But this one, when we want to find total area, we want to make this absolute value, and that gets everything above the curve and gives us the total area, which is 10. Okay. All right. All right, so let's do total area on this one. So first of all, set this up as an integral, and you remember you're going to do a little something to this when you get it in the integral. Okay. So see if you can set that up as an integral with this interval. Okay. So if we're going for net area, we would do this. But since we're doing total area, we're going to put the absolute value on there. So good job if you got that. All right. So now we're gonna find the area visually, and we'll learn better ways to do this coming up soon. But for right now, let's do this visually. So let's graph this. So we're going to have a graph here. All right. So here's our line, and this is actually what the line would be if it didn't have the absolute value. But since we have the absolute value, it's actually going to bounce right here, and it's going to come up on this side. Okay. So let me just white out this part here. All right. Okay, and we're going to go from -3 to 3. So -3 to 3. Okay, so it looks like we're going to have two triangles. Kind of seems like that's a common theme here. So two triangles, and so we have the base is 3 for each of these triangles, right? And then go ahead and find the height. So remember, to find the height, you're going to plug in these into the function here. All right, if you got 6, well done. Okay, so now go ahead and find the area of each of these triangles, right? And they're the same because they have the same dimensions, base 3, height 6. So go ahead and find the area of each one individually. All right, so if you got that both triangles are 9, 6 times 3 divided by 2. Good job. And so now what is the total area? Or in other words, what is the value of this integral? All right, so if you got 18, well done. Just add those together, right? Because we're talking about total area. So we just add up the area above and below the curve, right? Okay, in this case, we did the absolute value, and we graphed the absolute value, so we had them both above the curve anyway. All right, thanks for watching. Bring your questions to class or email me, and I will see you in class. Have a wonderful day.